So this video is about reviewing a concept that you all have learned before in a previous class about completing the square. And this is one of the concepts that you need to know for our next section because you'll be doing some of it throughout this new unit. So this video is just to serve as a review about completing the square. So we'll start out with the basics. What is completing the square? Well, completing the square is when you find a value for c that makes a function a perfect square. So in this example here, you have x squared plus 16x plus c. And the trick is that it's 3 steps to go about completing the square. The first step is you take half of b. Okay, and b is basically that middle term because in this case this is a quadratic and every quadratic is set up in this format of ax squared plus bx plus c. So you want to take half of b and then you want to square it. Okay, so whatever half of b is, you square it. So in this case b is 16, so you take half of that, and then once you take half you get 8, and then you square it. So when you square 8, you get 64. And so c is going to be 64. That's going to make it a perfect square. And you'll know this because if you try to factor it, you look for two numbers that multiply to give you 64, add together to give you 16. Well, that's nothing but 8 and 8, which can actually be written as x plus 8 squared. So that's what you're looking for when you're completing the square. You're looking to see what number is going to make it a perfect square. So basically when you factor, you end up with the same number in the binomials. So I want you guys to pause the video and I want you guys to give this a try. When you're ready to see the answer, press play. So hopefully you got this when you did it. B is a negative 49, so you take negative 49, you divide it by 2. That will give you a decimal, but I like to keep it as a fraction. So you square that and you get 2401 over 4, and that is the value of C that will make it a perfect square. And this concept evolves into solving. You can use the process of completing the square to solve, in this case, a quadratic. So the first step is that you want to do when you are solving by completing the square is you want to go ahead and whatever the constant is, whatever that c is, you want to subtract it over to the other side. So you have x squared plus 10x equals 11. And then from there you go through the process of completing the square. What's b? It's 10. You divide that by 2 to get 5. And then from there, you'll take 5 and then you'll square it. So 5 squared is 25. And from there, you are going to add it to both sides. Because when you add in a plus 25 on the left side, since this is an equation, whatever you do to the left side, you have to do it also to the right side. So you're going to add that to both sides. And then you'll have x squared plus 10x plus 25 equals 36. From there, you're going to factor that, that left side, which is nothing but x plus 5 times x plus 5, which is basically x plus 5 squared, equals 36. You'll take the square root of both sides to get x plus 5 equals a positive or a negative negative 6. Remember, whenever you take the square root of both sides, you get a positive 6 and a negative 6. And then you are going to subtract over 5 to get your answers. So you're not going to leave it like negative 5 plus or minus 6. You're actually going to do your two solutions. You're going to do negative 5 plus 6, which equals a positive 1. And you're also going to do a negative 5 minus 6, which is a negative 11. And those are your two solutions. Okay? So you can solve a quadratic by completing the square as well by basically going through the same process. So I want you guys to try these two problems. When you're ready to see the solution to the first problem, press play. And then pause it again, work on the second problem, and when you're ready to see that answer, press play again. So hopefully you got this for the first one. When you took half of b and squared it, you got a 25 that you added to both sides. Factored the left, simplified the right, took the square root to get a plus or minus 1, added 5 to both sides, and then got your two solutions. Pause it, work on B, and then when you're ready to see the answer for B, press play. And hopefully you got these two solutions for B. Now the same concept works when A is not 1. When A is not 1, there's one extra step that you have to do before you can actually complete the square. And that step is to, since whatever that A is, you divide it to every single term. Okay? Now if you want to go ahead and subtract over the 5, you can, because again your constant has to be on the other side, but no matter what, A has to be 1 in order for you to complete the square. So this is going to be 7/2 x equals a negative 5/2. So then you go through the process again, and you'll take and you will complete the square. So our B is a negative 7/2. Okay? Now when we take half of that, we are going to have to keep, change, flip. Okay, and you guys bear with me while I do this. So when we keep, change, flip, that will end up giving us a negative 7/2 times a 1/2, because you flip the denominator, which is a 2. So you're going to end up multiplying those together. Okay, so we're going to multiply those together, and we're going to get a negative 7/4. That is what we are going to add to both sides. Or sorry, actually, nope. Just kidding. We're going to square that, and then whatever that number is, we're going to add to both sides. So we take half of B, which is negative 7/4, and now we're going to square it. Okay, now we're going to square it. And when you square negative 7/4, remember you square the top and you square the bottom. So then that's going to give you a positive 49 over a positive 16. Okay, and that's going to be the number that you add to both sides. Remember, whenever you square a negative, you get a positive. Okay, so then that's what you're going to add to both sides. So you'll have x squared minus 7/2x plus 49/16 equals a negative 5/2 plus 49/16. Okay. So the process still stays the same. You just have to be careful when you have an A and you divide and it doesn't give you a whole number. You are going to be dealing with some fractions. So when you actually factor the left side, whatever you got when you took half of B, which was that negative 7/4, that is going to be the number that's inside of that parentheses on that left side. Okay? Because the only way that you're going to get that perfect square trinomial is by finding out what number multiplies to give you 49/16 that adds together to give you a negative 7/2. And this is the easiest way to do it. So whatever half of B is, that's what goes in that parenthesis. It also works when you don't divide by A, just as a heads up. It works for those other problems. And then when we add negative 5/2 and a 49/16 together, that's going to give you, if you had a common denominator of 16, that would have been a negative 40/16. So when you add those together, you're going to have a positive 9/16. Okay, you can always double check, use your calculator if you don't believe me. I didn't show out the work, but getting a common denominator will get you 9/16. So then we take the square root of both sides. And that's going to give us a plus or minus. When you take the square root of a fraction, you take the square root of the top and the bottom. Luckily enough, those are perfect squares. So that's going to give us a 3/4. And then we're going to add a 7/4 to the other side. Now when we add 7/4 to the other side, we're going to get 10/4, which simplifies down to 2/5, or I mean 5/2, excuse me. And then when we add over 7/4 and we subtract a 3/pi, we're going to end up with a 1. Okay? And I know I didn't show all my steps there, Again, I am typing this all up, so trying to show all the steps would be a little much, but make sure that you guys show your work there with the actual adding of 7/4, and then do a positive 3/4 plus 7/4, and then a negative 3/4 plus 7/4, and you'll get that. So I want you to pause, give this one a try, give these two a try. When you're ready to see both answers, press play. Here's the answer. And here's your answer for this one. This one, when you took the square root, it wasn't a perfect square, so you just leave the radical there. And I did forget the radical here, sorry. So this is actually your final answer. Okay? The last little bit that that I have for you is that you can complete the square with everything on one side, and honestly, it's the same process. You still take half of b, you still square, but instead of adding it to the constant, you're going to subtract it. And again, the reason why you subtract it is because it's on the same side. Okay? So take a look at how you go about completing the square with everything on one side.
Excuse me, teachers, at this time, would you please release?
So you still go through the same process. You still take half of b and square it. So our b is 4. When you take half of 4 and square it, you get 4. So you add that to the first part, and then you subtract it from the other side. Okay. Now from here, you group that perfect square trinomial, and that's what you factor. And the negative 3 and negative 4 stay on the outside. And that's how you complete the square on one side. Now, when a is not 1, you have to do something that's a little bit different, okay? Now, when we were solving it and a was not 1, we had to divide everything over. When you're trying to complete the square with everything on one side, you don't divide it over. You factor out the GCF from the first two terms, from the a x squared term and the bx term. So when you do that, it's actually a negative 5 that they have in common. And the reason why it's a negative is because that leading coefficient is negative. And the thing is you want it to be positive when you're completing the square. So that concept still applies. Okay? So this is how the setup will be. Remember, you subtract over. I'm going to do this down here. Remember, you take half of b and square it, and that will go in the blank there. And then whatever's in that blank, you're going to subtract it over here. So we're going to take half of b, which is now 2. Not the original b, but the b that we get after we factor out. So when we take half of b and square it, well, half of 2 is 1. When you square 1, you get 1. So you have negative 5x squared plus 2x plus, okay, and you take half of b and squared it, you got 1. Okay. And the next difference between when a is not 1 is that you're not going to subtract 1, you're going to subtract a negative 5. So whenever there's an a that you factor out, whatever that value is, you multiply it by the number that you get when you took half of b and squared it. So we're not going to subtract 1 again, we are actually going to subtract a negative 5, which technically is going to be adding 5 because you know 2 negatives make a positive. Okay? So again, when a is not 1, you factor it out from the first two terms. You complete the square like usual. That's how we got 1. But then what we subtract on the same side to the 6 was the product between the negative 5 that we factored out and the number we got when we took half of b and squared it. So we'll basically have negative 5, then this factors down to be x plus 1 squared. And then when we have a 6 minus a negative 5, that's going to be nothing but a plus 11. And that's how we complete the square with everything on one side. I want you guys to give these two a try. When you're ready to see your answers, press play. All right, so hopefully when you worked on this problem, these two problems. This is the answer that you got here, as well as here. Remember, when you take half of being squared, you get a 9/4 that goes in right there. But remember, what you're subtracting is what you get after you multiply -4 and 9/4 together, which is a -9. That's how you get 27. Similarly, down here, when you take half of being squared, half of 8 is a -4. When you square it, you get a 16. But you're not going to subtract 16. You're going to subtract the product between 2 and 16, which is 32. That's how you get that answer down there. If you guys have any questions, you need to let me know. If you don't, though, there is going to be an assignment for you that works on completing the square. Actually, I think it's going to be two or three assignments. So I need you to sign up for Khan Academy. Right now, after you've watched this video, sign up at khanacademy.org. Log in. If you have used Khan Academy in the past and you remember what your login is, didn't use that. But if you don't, create a new one. Either way, I need you to have an account. And please write down and don't forget your login or the password, because that's something that I cannot recover. You can either use your personal email or you can use your school email. I probably suggest school email just so you can get used to using it. Once you've created your account, you want to visit khanacademy.org/coaches after you've logged in and created your account. From there, you want to go to the add a coach field, which is usually at the top right corner, and then type in this class code, which will basically add you to my class. You will be assigned an assignment that will be due on Friday, and that will be your homework. If you guys have any issues with signing up for Khan Academy, please let me know.